Hi everyone, this is my NEA CS testing section. So today we're going to be going over my my dynamic simulation bot. Uh, and yeah, let's just jump right into it. So let's run the code. Test 1 was that the first window represents the random and manual buttons clearly. So as you can see, as soon as I run the code, we're presented with two buttons, random and manual. So that's test 1. Test 2 is verifying that both buttons work. If random is clicked, it should take us directly to the simulation screen. Yes. And if manual is clicked, it should take us to the simulation settings screen. Also yes. Great. Since this was an investigation, there's no back button as you're meant to go through it. So throughout this entire testing video, I will have to restart my code multiple times to maybe change conditions or retry things. And on second thought, that could perhaps be a way to improve my code further. Test 3, simulation settings screen display. Simulation settings screen has clear labels and appropriate text boxes to fill those parameters. So simulation settings screen comes after we click manual. Yes. And this is the settings screen. So we have clear labels, lane ratios, lane 1, lane 2, lane 3, lane 4, and appropriate text boxes to fill in those parameters. Test 4, simulation settings screen accessibility, easy to navigate. So let's just try that out. I've made it so boxes will change color as you click them, so it's easier for the user to know what button they're on. And it's pretty easy to type it in. It's just like any other thing. It was interesting to build this in Pygame, but even with the buttons, you can click them. So yeah, there was a slight mishap clicking random to manual. It seems like it selected two, but double clicking it fixes that. Um, Test 5, simulation setting screen button works. So simulation setting screen only has three buttons and they are selected. So let's just try random. We'll put null values for 1 second, 40, 30, 40, and let's just pick random and we get in. And yeah, so as you can see, the button we clicked was random and the core mode is random, so that means the buttons do work. One more test for the same thing where testing simulation settings button work is that if fixed is clicked, a new text box should appear to allow the user to input a time value. So fixed means that a car will be introduced and every n number of seconds, and this interval is allotted by the user. So I clicked fix, this text box popped up. If I click random, it would disappear. If I click fixed again, it will come back. So let's just put random values for lane ratio. So let's put 10, 10, 5, 5, min speed 30, max speed 40, 20. So as you can see, the car mode is fixed and the vehicle interval is 2 as defined. And also vehicles are coming in every 2 seconds. Yeah. Test 6. Users can change their mind on simulation setting screen. This was basically just that once a user puts a value, they can change it. So for example, if I put 40, 45, I can go back here and change it by pressing the delete button to 70. And if I click random, I can go to manual. If I click manual, I can go to fixed, and I can just alternate between them any. Test 7, test invalid inputs. Simulation won't begin until all invalid inputs have been changed to become valid. So I'm on lane 1 right now, and let's see if I can type letters, YG. And let's just fill out everything else. 34 and 12, max is 50, 40, 20, 30, and the code crashed. That was not really meant to happen. Uh, but technically, it does meet the requirement that the code is not going to begin until all valid inputs have been put in. Since it's an investigation, I believe that this should be okay, but also a place, a way I can expand on my code. Um, yeah. So test 8, all parameters should be filled before the user is allowed to start. So let's just put instance 30, instance 40, 30, 40. Let's make this random. 10, 20, 25. And as soon as I filled it and clicked away from the last text box, it threw me into the simulation because number one, all parameters were valid, and number two, all parameters had been filled. Until then, the user will not be allowed to enter the simulation. It will just either crash the code or wait until all parameters have been filled. Test number 9. Once entering the simulation, all aesthetics are clearly displayed. Four roads of both simulations side by side are drawn and are identical. So on the left side, we have the dynamic simulation. On the right side, we have the fixed simulation. They're both identical in terms of the number of lanes, where the lights are, and the number of segregation, lanes within lanes, you can say. There are four roads, one, two, three, four, two lanes on each road. Traffic signal and its state is clear, as shown below. A bar drawn in the centers to separate both simulations. Yes, and real-time vehicle counts for each lane, as shown lane 1, lane 2, lane 3, lane 4, and this updates as vehicles are introduced and as they leave. Test 11. Buttons are available to user, and that is there. So we have the buttons which are required. Add car to lane 1 to 4. Add emergency vehicle is over here, and add car is over here, and end simulation is over here. So the user has all buttons they should have access to. Next test number 12, the add car as per simulation conditions works. So the add car button should ideally add cars based on the lane ratio. So if I add a car, it should be most likely to enter between lanes 2 and 3, less likely to enter through lane 4. So let's just click this button many times and see how the distribution of how cars are entering. So as you can see, a lot of cars entered lanes 2 and 3 because they have a higher ratio, and the least number of cars entered lane 4, as expected. So that button does work. The add car to lane button allows us to manually add cars to lane regardless of the lane ratio. So add car to lane 1, added a car to lane 1, add car to lane 2, added a car to lane 2 on both simulations. So with lane 3, so with lane 4. Then under the same test, test number 13 was add car to lane, and test number 14 was add emergency vehicle button. So add emergency vehicle button should add an emergency vehicle to the same lane in both simulations, but the lane that it's added in is random every time. So let's add an emergency vehicle. Yes, it entered both lanes. It entered lane 4 in both cases. So yes, that does work. Test number 15, cars in the simulation should behave like actual cars for accurate results. We'll actually cover this more in depth later, but as you can see, cars are moving as they should. There are no actual anomalies. Test number 16, clear distinction between normal cars and emergency vehicles. So as you can see, normal cars are signified as blue, but if I add an emergency vehicle, it's flashing red and blue. So it's very clear, and it also moves quite a bit faster. Test number 17, when anything enters a simulation, it should enter both simulations at the same time. So let's just try by adding cars to lane 1. And as you can see, it entered both simulations at the same time. Yes. Vehicle count for each lane represents the number of vehicles in each lane and is accurate in real time. So let's just add 5 cars to lane 4 and see how the number changes. So 1, 2, 3, 4, 5. Lane 4, 5 vehicles. Lane 4, 5 vehicles. Now let's just keep our eyes on lane 4 and see what happens as they leave. Okay, so the vehicle count only reduced not when they left lane 4, but when they left the entire simulation. I guess that could be a way, a short shortcoming because it's not updating immediately as soon as it leaves the lane. Uh, but yeah, test number 19 under uh, user testing. Test number 19, vehicles can continue to be added beyond the screen. So let's just keep adding lane 1, boom. Yes, we've added many cars to lane 1 and now the screen is ended. But can we still continue to add cars? Yes, so as you see on the right side, we can still continue to add cars far beyond the screen and we'll increment the counter. And when the light turns green again, let's wait for the light to turn green again for lane 1. The light turned green and cars were coming from behind the screen and were behaving correctly. Vehicles don't crash, vehicles don't meet slash touch in the simulation. So in the simulation, the car should not touch or meet in any place. So let's just watch to see if that is actually the case. So when the cars are moving in a straight line, they are not. But if you just spotted back there, two cars did touch. So when cars are turning, they tend to clump up sometimes, which should not ideally happen. But on the most part, cars are not crashing or touching, maintaining accuracy. Test number 21. When the end simulation button is clicked, the user is redirected to the statistics screen. So let's click end simulation. And boom, we are on the statistics screen. Test number 22. Statistics screen. Users presented with all data from the simulation through visual format, clearly showing the percentage differences. Percentage differences and the visual format of a histogram and two bar charts. We will come back to the statistics screen later on. Okay, let's go back to okay. So now on to modular testing. Test number 1. So let's just start with random conditions. We clicked random, so the simulation conditions have been randomly defined, and the lane ratio is stated above. Um, Vehicles should stop at red lights. So as you can see, when the light for this road is red, the vehicles are stopping, and they're only going when it is green. So let's just add some cars to maybe lane 3. And as you can see on both simulations, cars have stopped because the signal for them is red, and as soon as it turns green, they go. Test number 2 for modular testing. Please keep in mind we're on the modular testing table now. Vehicles stopping behind stationary cars. So, let's just take lane 2 as an example. Let's add a lot of cars. Okay, so in lane 2, the light is red, so cars are stopped, and the cars behind them are stopping because the car in front of them is also stopped. So yes, vehicles are stopping behind stationary cars. You can also not see any car drive through another car. It's if the car in front of it is stationary, it would stop. Vehicles accelerate in open lanes. Okay, so to test this out, I would like to change the simulation conditions a bit. So we're gonna restart, go into manual, just do 1, 1, 1, 1. Doesn't matter. Let's do this manual. So we're gonna set a really low min speed and a really high max speed, so it is clear to us when a car is slowing down and when a car is speeding up. Okay, so let's add a car to lane 1. So you can see this car is slow and the other two cars are, we don't know their speed actually. So let's add, how can we test this? Ooh, did you see that over there? So you might have to reverse the video. But there was a faster car. When the gap opened up between the faster car and the slower car, it sped up and slowed down to prevent a crash. Let's just try to see if we can catch something like it again. See, do you see this car accelerating when it has speed and decelerating when it reaches the safe difference? So, yeah, that's an example of this in action. Okay, vehicles decelerate when behind a slower car. We just saw that as well. Emergency vehicles ignoring red lights. Okay, so let's just add some cars to the simulation. Okay, so in both simulations, an emergency vehicle should ignore a red light and just drive straight through. An emergency vehicle would only wait behind stationary cars. So let's add an emergency vehicle. Yes, um, the light was green, so let's add another one. Just you can see there that it ignored that red light. Okay, moving on. Test number 6, dynamic traffic light changing in dynamic simulation. Okay, in order to carry this out, what we'll do is random. Okay, so as you can see, the lane ratio here is 2 to 0 to 1 to 0. This means that lane 2 and lane 4 will have no cars regardless of how many cars they add as per simulation conditions. So no car enters lane 2 and no car enters lane 4. That's because of our lane ratios, right? 1 second. Yeah, this would be a better way to explain. So, what we're testing right now is the dynamic traffic light will change in the dynamic simulation. Signals will switch dynamically based on traffic in the lane. Empty lanes should be skipped. So, as you can see on the right side with the fixed system, 5 seconds, and then the light is red, and it waits. But if we shift our focus to the left side, we have a green light, and we immediately skip all other 3 lanes because they have no traffic whatsoever. Let's add more cars to lane 4, and then let's add some cars to lane 2. So now the light for lane 2 is green, light for lane 4 is green, skip lane 1, go to lane 2, skip lane 3, go straight to lane 4. So the dynamic system is adapting based on the number of the vehicle counts in each lane. Test number 7, fixed signal timing. Signals should switch at fixed intervals. So let's just verify this. So we're looking at the right side now. I'm using a timer, so start. That was 4.9 seconds. That was 5.2 seconds. So it has been coded to be exactly 5 seconds. It was just some human error. But yes, this fixed signal changes at fixed intervals. Um, Test number 8 is normal car behavior in the intersection. Cars will go left or straight based on the lane they enter in. So in this simulation, we have assumed a right to be free. So if a car enters the left lane, they will continue the rightmost lane. They'll continue to go straight, and if they enter the center lane, they'll take a left. So as you can see, every single car in this lane on the right side will pass straight when the light turns green, and this light will take a left um, with respect to itself. So this car took a left, and these cars went straight. Number 9, dynamic behavior of red light with emergency vehicle in dynamic system. So, let's just add a lot of cars to each lane. Okay, now let's add an emergency vehicle. And as you can see, this actually caused a problem because the emergency vehicle had a clear stop in front of it. So it ran the red light, but the other cars were programmed to stop when it got too close to a vehicle, and it caused a jam. So we're looking over here. Um, this is a bug, but it's a very rare scenario. So I'll have to talk to my advisor to see if it's okay. But yeah, um, let's try again. So on the left side, as soon as an emergency vehicle is added, um, let's just do it under manual conditions because that would be a bit easier for me. One, 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 fixed, one. Sorry, I know the problem. The problem that happened here was I accidentally just put 5 as the max distance, and that raised a small problem with the. Yeah, okay, so let's just add a bunch of cars to the simulation. Okay, now let's add an emergency vehicle. So an emergency vehicle came in lane 1. You might have to rewind the video a bit, but an emergency vehicle came in lane 1. Lane 1 immediately turned green, but in the fixed system, the emergency vehicle is stuck behind a car and won't be able to pass until the light turns green, in which case it does pass. Let's just try it again. Emergency vehicle entered in lane 1. Since lane 1 was empty in the fixed system as well, it was allowed to pass, but if you go back in the video, the light on lane 1 actually turned green and all other lights immediately turned red. Let's try again. 3, 2, 1. All lights turn red, but the lane which was introducing the emergency vehicle turned green immediately. Again, let's try again. And again, so we're focusing on the left screen here. As soon as I introduce an emergency vehicle, that light immediately turns green, and then we shift back to the order we were in before. Um, Test number 10. Test application of lane ratios to the simulation. Okay, the easiest way to test this would be to set some of the lane ratios to 0. Um, Random. Let's just try again. So yeah, so 0, 2, 2, 1. So by adding cars, there's no way to definitively test this because um I used a random system. So 2-to-1 ratio just means that a car is twice as likely to enter lane 2 or 3 than lane 4. But we can test this. We will know this works if no car enters in lane 1. So just add a lot of cars to the system. They're all entering, but not a single car enters lane 1. And if you look in general, more cars are entering lanes 2 and 3 compared to lane 4. So yes. Test 11, random parameter generation. When random is clicked, the simulation conditions will be randomly generated and will be in a reasonable range. Through all our tests, we can see that that has been true. Yeah. Um, uh, Lane ratio is 2-2-2-3. Car mode is random, and the vehicle interval is 1 second, which is pretty realistic. Test number 12, vehicle speed range. Ensure all vehicles have a speed within the defined range. Let's just test that. Manual. So let's make it really high at first. So 90 and 100. 30. We'll also do test. Yeah, sorry. And then min distance, let's do 30 and 40. So again, since it's difficult, since there's speed range is based on pixels per second, it's difficult to definitively test it. But what we can do is when it's higher, just watch them go faster, and when it's lower, we'll watch them go slower. So you've watched them at the speeds 30 and 40 a lot already. So let's just watch them at speed of 90 and 100. This might get a bit messy because this is very unrealistic speeds at intersections, but it will show us that the speed range does have an effect on the simulation. Wow, you can just see how fast the cars are moving. But yes, speed range is working. Test number 13, yellow light timing. No car passes intersection while light is yellow. Um, let's see how easy it would be to spot. So let's just add a lot of cars to lane one. So you can see that the cars stop not when the light turns red, so let it come back to lane one, but when the light turns yellow. So green, 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 yellow, and that stopped. So you can very clearly see that the cars are stopping not when the light turns red, but when it turns yellow, which is accurate. Now on to additional testing. This is mainly regarding the statistics page. So let's end the simulation. This is this page. So all statistics are displayed on screen. Statistics screen displays average wait time in the bottom left. Throughput comparison, uh, which is on the right, and the percentage improvement, and also a histogram which shows the number of vehicles and their waiting time. So we can see the distribution of waiting times of each vehicle in both the dynamic and fixed system. It's pretty easy to understand. There's a helpful key on the top right, and scales on both sides. This was made using the matplotlib function library. Test number 2 in additional testing, verify statistic accuracy for both intersections. So the way we're gonna verify this is we're just gonna use it for really small numbers. So random add car. So we have the throughput should now be 1 and 0. And that's correct. So throughput for the dynamic system was 1 as one car went through, and for the fixed system it was 0, and the average wait time is 0 for fixed, precisely because no car made it past the simulation. Um, but yeah, so that's pretty accurate. Number 3, percentage change is correct. Uh, let's just try this as well. Random. Let's fill up the intersection a bit. Okay, let's end the simulation here. Okay, so a dynamic average wait time was 11.64 seconds, and fixed average wait time was 12.57 seconds. Just quickly using my calculator to test this percentage difference. That is correct. And now for the throughput comparison, that is also correct. So yes, the percentage improvement is accurate. The tooltip functionality. So this is access to the buttons here. Let's just see how it works. So I select this. It allows me to move the graph, zoom in. This is not something I coded in directly. It's a function with the matplotlib library that I used. But it's pretty useful. And the last test is simulation not crashing under unrealistic conditions. So what we'll do now is we'll add a lot of vehicles and see if it crashes, and then we'll add a lot of emergency vehicles and see if it crashes. Random. So we're now at the stage of 25, 5, 8, 34 cars, 15, 5, 5, 23 cars. So seems to be going pretty well. My laptop did get pretty slow, but it seemed to be working pretty well. Yep. Okay, now let's just add a lot of emergency vehicles. So with the dynamic system, it's coded as that adding an emergency vehicle would make that light immediately green. So let's see how would that affect the system. I have coded it so that there will only be one green light at a time, so it would prevent absolute carnage. But let's just add a lot of emergency vehicles to the simulation and see what happens. So as you can see, it's faring a bit better than I thought. No cars are crashing, and but we are seeing a lot of emergency vehicles run the red light and kind of intersect with each other. Um, Something I'm fine with because this is a very rare scenario, and cars touching does not necessarily mean cars crashing. So yes, that's all of my tests. Um, we will go over the result, but I'm pretty happy with how it went. Thank you so much for watching, and I hope you liked it.